Hey everybody, today we're going to talk about simplifying radicals, or as I like to call them, radicals. Alright, so how do we simplify a radical? Well, first you might be wondering, what is a radical? Well, a radical is one of these things that you've seen before. It's a square root, okay? This is the inverse operation of squaring something. So for example, I could say like x times x is equal to x squared. And then to undo that operation, okay, I would take the square root. So the square root and the squared cancel each other out. So that is what a radical is. All right, so we have these things called perfect squares. They literally come from perfect squares. So something like this, for example. Okay, this is a 3 by 3 square. Well, what's the total area in here? If I did 3 times 3, well, that would be 9. So guess what the square root of 9 is? 3. All right, so it's the number that when multiplied by itself gets you to, so a number multiplied by itself, for example, 3 times 3 gets you to 9. So 9 is a perfect square. So we get our perfect squares by doing just that. So we have unofficially 1 is a perfect square, 1 times 1 is 1, but we start at 2 times 2 is 4. 3 times 3 is 9, 4 times 4 is 16, and we just keep going down that line. And so these are our perfect squares. Okay, so those are handy to remember. Again, you get those by doing a number times itself. So sometimes when I'm having my students write their list out, they might write what the square root of that number is above, like this. So I know that the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So let's go ahead and dive into how we simplify these things. So some of these are beautiful. These are what we would call our perfect squares. So these simplify exactly. So for example, if you hop onto your calculator, all right, so if I tried the square root of 64, again, that's what is the number that when multiplied by itself gets me to 64. So that number in this case is 8. All right, so the square root of 64 is 8. All right, so square root of 64. And actually, this is a little fun fact too. There's actually another number that when multiplied by itself gets us to positive 64. So we know that 8 times 8 is 64. Now, is there another number that when multiplied also takes us to 64? And maybe you're thinking, what about negative 8 times negative 8? That's also positive 64, right? So anytime we take the square root of something, we unofficially take the positive and the negative version of that, because two negatives multiplied against each other gives us a positive. So the square root of 4 here is both positive 2 and negative 2. Square root of 25 is both positive 5 and negative 5. And then you might not know the square root of 121, but again, that's what our calculators are for. 121, and we see that is a perfect square, and it is 11. So it's going to be positive and negative 11. And that's how we list those. You're welcome to also list it like this. You could say 8 and negative 8. If you want to include that in a set, as in brackets, you can do that as well, but this is the more common way that you'll see that. All right, so what happens if it's not a perfect square? Okay, what if it's not a perfect square? So actually, you can ignore that. And so this is what we do. What if it's not a perfect square? So do you know what number when multiplied by itself is 20? Well, it's actually going to be a decimal. And it goes on forever and ever and ever. So we get this long, ugly decimal. So we try to figure out how to simplify these things. So the way I like to explain it to students, so before we dive in, let's say I had 10 over 12, and I said to simplify that fraction. Well, we know that we could cut both the top and bottom in half, and we could reduce them to 5 over 6. So if I looked at that in my calculator, 10 divided by 12, we get that. And if I tried 5 divided by 6, you see I get the same repeating decimal. So while these two numbers, these two fractions, they look different, they actually are both still equal to the same thing, and that'll be a helpful strategy as we break down our as we break down these radicals. So again, we saw that the square root of 20 right here was not a perfect square. It doesn't break down to that whole number that we were seeing on the slide before. So this is how we simplify it. Again, kind of comparing it to simplifying a fraction. So you want to start by, I always tell my students to list out your perfect squares first. So we had 4, 3 times 3 is 9, 16, 25, okay, and they keep going on. So always list out your perfect squares, and the goal here, it makes it really easy. We want to start from the biggest numbers to the smallest numbers. So the goal is to look for the biggest number that divides nicely into our perfect square. So step 1, I'll say to write out your perfect squares. Step 2, find the largest perfect square that divides nicely into the given number. And then step 3, we will simplify the perfect square. All right, so just some light notes there. So let's look at our perfect squares. So obviously it can't be a number bigger than the given number 20, right? 25 would never divide nicely into 20. So we're looking for the one that divides nicely into there. So does 16 divide nicely into 20? No. Does 9? No. Does 4? Yes. All right, so just in the same way that 4 times 5 is 20, we can also say that root 4 times root 5 is equal to root 20. Okay, but we use perfect squares because we know what the square root of 4 is, right? What is that? Well, it's 2. So our perfect square will always simplify it down into a whole number. And then the square root of 5 does not simplify any further, and this would be our final answer. Okay, so again in your calculator, let's look at the square root of 20. And let's look at what I simplified it to, 2 times the square root of 5. And you'll see we have the same decimal values, just like how we explained earlier with those fractions. So this is a good way to check yourself in your last step to make sure that your two numbers are still equivalent to each other, even though they look different. Let's try out another one. All right, so again, we can kind of ignore this jazz. All right, I'm going to list out those perfect squares again. 16, 25, 36, 49, okay, 81, okay, and obviously the list goes on. It's good to know your perfect squares up to about maybe like 14 or 15. Those are good ones to know. All right, so now I'm looking, what's the biggest number? Remember, we want to work down this way through our list. And if you're not sure, you can go into your calculator, and you have a couple ways of trying. You could just start here and do, okay, what's maybe 49 divides nicely into there. So 72 divided by 49, and I see it's not a whole number. What about 72 divided by 36? And you can just work your way down the line that way. All right, and look, 36 divides nicely into 79. So he's going to be the biggest perfect square I have to work with. So the square root of 36 times the square root of 2 is equal to the square root of 72. Again, we know what the square root of 36 is. What is it? It's a perfect 6. So we write this as 6 times the square root of 2. All right, again, in your calculator, double check yourself. Square root of 72, and then we had 6 times the square root of 2. And again, just making sure that those are equal numbers, that tells us that we did simplify it correctly. And actually, the way that you know you're done is if I can fit, as long as I can't fit any more perfect squares into this number, then we know it's simplified. All right. So we got a couple to practice. If you want to pause your note video right here, practice these real quick, and then you can unpause your note video and check your answers. And again, a helpful strategy is to write out your perfect squares along the top, and then sometimes I'll tell my students, if it's helpful, write what the square root of that number is. All right, so it would look kind of like this. and that will just make an easy point of reference for you. All right. So again, pause your video and then come back to check yourself. All right, so if you're coming back on, you can check your answers. So some of these ended up, maybe you got a little tricked up at the last two. Hopefully you got these guys right. Again, remember you're looking for your greatest perfect square. Now here, if you thought that 4 divided nicely into 98, which I think it does, you know, you see you might have ended up with a different answer than me. Remember, we're looking for the largest perfect square that fits into there. So 49 was our largest perfect square. Square root of 85 does not simplify any further, and the reason I know that is because none of these numbers divide nicely into 85. Therefore, he just stays as a square root of 85. He's in his simplest form. It's just like if I had the fraction, I don't know, like 3 over 7. I cannot reduce that fraction anymore. He's in his most simplified terms, okay? And then the square root of 36 we know is 6. Now you could have also said positive and negative 6. Awesome. Now, don't remember that. Okay, there's one more thing I did want to cover.